Hi students. So in previous video we learned collisions as a first part, no, like inelastic collision, elastic collision, and perfectly inelastic collision, no, and the formulas and all these one, no. So we derived there. So please go and check that first part and come back to the second part, no. So we'll try to complete the remaining part of our collisions one, no. So let us see what are these one now, right? So just go through that first part, no. Second part, now we'll discuss one application here like a bouncing ball, right? So let us take one ball here, one ball we can take it now, and we are going to drop it from certain height here. So from certain height, so suppose it is h naught is the height, from this height we are dropping now. So when we are dropping, what will happen now? This will come down and it will hit to the ground and it will bounce back, not to the same height. Why? Because when it is impacted with this one now, it is going to lose the energy. So due to this, so therefore it will not come back to the same height. So here from first one now, at the instant, initially we are dropping from height h naught. We are dropping only. So here it is going to take place now. For our convenient part, we will draw like this now. So suppose it will come down, right? So it will come down. So it will hit to the ground, and then afterwards it will be rebounds back to the some height here, right? So like this it will come and it will rebound back to the some height. Again it will come back to this one, no? So again it will hit to the ground and again it will be raised to certain height. So again it will be bounced right here. Again it will be bounced here, no? Therefore it goes to certain height. Again it will be come back to this one now. Clear? So now this will continues until therefore it is going to stop now. Now let us see. So this is our first bounce, right? So first bounce now. Therefore this, what is this type of collision now? This type of collision is nothing but a inelastic collision. Therefore let us take this is your coefficient of restitution now. E is the coefficient of restitution. So now we will consider one more thing now. Therefore it is coming down, hitting, and after first bounce, this is the first bounce. After first bounce it is raising to the height of h1, and therefore again it will hit now. This it will be the second bounce. After the second bounce it is going to reach to the height of maximum height of h2. So this is the third bounce. Therefore again height is h3. Now we will derive a coefficient of restitution equation now. So we know what is the coefficient of restitution now. That is velocity of separation by velocity of approach, that is relative velocity. So that is nothing but v2 minus v1 by u1 minus u2. This is what relative velocity of separation and relative velocity of approach now. So here where it is approach now, from here to here, this ground is not moving. So from here to here it is the velocity of approach, from here to here velocity of separation now. Clear? So velocity of approach, it is falling down. So free fall now. So it is under the gravity. With what velocity is coming down or now? This is not moving. This is only a velocity of approach now. So what will be the velocity? Suppose it will be v0 will be the velocity. So then after this one, no, it will be rebouncing back, no. So v1 will be the velocity of separation. What we can write it now? So velocity of separation is nothing but v1 by it is v0. So what you can write it now? So v1 it will be equal to e times of v0. That means after first bounce, what will be the velocity? E times of initial velocity. Same way we can write it as, so here therefore here we consider that air resistance is neglected. So when go here, again come back here, no, it is going to hit with a speed of v1. Again it will be going to rebound back with a speed of v2. Assume that velocity after the second bounce. Again we can write down the coefficient of restitution here. So that is velocity of separation v2 by v1. We can write down v2 is equals to e times of v1. So we can combine these two equations, no. So what I can write it now here. So velocity it will be equal to e times of next, that is previous velocity onto this. So we can write down in the place of this e1 v1 is there, no, we will substitute here, no. So v2 is equals to e times of v1 value is nothing but e into v0. So therefore v2 is equals to e square v0. So observe this now, this is 1 e power 1 v2, therefore e power 2. So like that, therefore v velocity after the nth bounce, it will be equal to e to the power of n into v naught. This it will be the relation. So velocity after nth bounce, it will be equal to e to the power of n into velocity at first impact onto this. Clear? So this is your velocity after nth bounce. Now we will write down one more formula here, no? Right? So velocity, what is the velocity here now? Velocity for first one, no? So v naught, we can write down square root of 2g into h naught, because it is falling freely. So similarly, it is going up, again it is coming from height h1, no? So v1, we can write down square root of 2g h1. Can I write it now? So again E is equals to, what you can write it now? We written that, so here we written, so v1 is equals to this one, no? So here E is equals to v1, v1 is nothing but a square root of 2g h1 by square root of 2g h naught. So you can square it onto this one, no? That implies E square is equals to h1 by h naught, that implies h1 is equals to E square, therefore into h naught. Similarly, we can write down for second bounce here, no? So second also will get it as, similarly you can derive, no, h is equals to E square into h1. Clear? So therefore EH2 you can write it, no? Then again we can combine these two. So what you will get it now? We can combine these two. So h2 is equals to E square into h1. h1 is nothing but again E square into h naught. So h2 is equals to e to the power of 4 into h naught. Right? So what you can write it now? 2 second bounce, height after second bounce is equals to e power 4. Generally we can write down h height after nth bounce, it will be equal to e to the power of 2n into h naught. This is your height after nth bounce. Clear? So here in this way we can derive the equation for height after the nth bounce, height after the like any nth bounce we can calculate. Velocity after this nth bounce also we can calculate it now. So one more way, okay, one more thing we can just recollect it, no? So one more concept is there. So let us see here now. This is, we are dropping from certain height h naught. So it is bouncing like this. It is bouncing like this, bouncing like this. Okay, so on. It is going to continue. Correct? So this is what? This is your first bounce. This is your second bounce. This is your third bounce. We got it. What are the relations now? Velocity after nth bounce is nothing but e to the power of n into v naught. So height after the nth bounce is equals to e to the power of 2n into h naught. Clear? So these are the important formulas now you can remember onto this. So mostly in the NEET and JEE mains level you can expect the questions based on this only. So right. So now one more also we can write now. What will be the total distance travelled until it is going to stop now? Therefore first distance, how much distance it will travel now? First distance, therefore total distance, let us h know. For total distance is nothing but a h naught. Next one, therefore after this one, no, it is went to h1. This is your h1, went to up h1 and again come back h1. Therefore 2 times of h1, therefore 2 times of h2, so on. So here you can write it down. Therefore h naught plus 2 times of h1. h1 first after this one, no, 2 into e power 2 into h naught plus 2 into h2, that is nothing but a e power 4 into h naught, so on. Right? H naught taken common here now. H naught, so 1 plus 2 e square plus 2 e to the power of 4, so on. Again we can rewrite it as h naught, it will be equal to 1 plus, here 2 e square taken common, no, 2 e square taken common, 1 plus e square plus e power 4, something like this you can get it now. Right? So here if you take this is like a, this is nothing but a geometric progression, no. What will be the sum of this from sum of this infinite terms now? Right? Sum of this now. So here you can write down sum of these points now. First term, that is first term by 1 minus common ratio. Common ratio is e square by 1. So e square by e power 4 by e square, that is numerator, you will get it as e square now. This will be the sum of this one, no. This is sum of these terms. Clear? So we can write down h is equals to h naught into 1 plus 2 e square into 1 by 1 minus e square. So simplify this one, no? You can get it as h naught into 1 plus, this is 2 e square. So you can simplify here. So you can write just mathematics, no? So 1 minus e square plus 2 e square by 1 minus e square. 1 minus e square, right? So e minus e square plus 2 e square, that is nothing but e square, no? H naught 1 plus e square by 1 minus e square. This is your height, I mean distance, total distance travelled. So until it is going to stop. Clear? So these derivations are not required now, right? Only even board also it is not required. So but like JEE mains, no, you might have expect this type of questions now. Similarly, I will give a small work now. Therefore, you can write it. What will be the total time taken now? What is the total time taken now? Total time taken is nothing but a t naught. Time taken from here to here is nothing but t1 means this is t1, this is t1. Therefore, 2t1 plus 2t2. So on. Therefore, you can write it now. What will be the time taken now? Time it will be equal to square root of 2h1 by g. So substitute here now, like that 2h2 by g, h1 by g, t1. t2 like that you can substitute it now. You can solve it now. Mostly you can get it as 2h by g into therefore 1 minus e by 1 plus e. You might have expect this type of result out to this. Okay. So not 1 plus e by 1 minus e, I think there. Just observe this one. Try to solve it. So whether it's correct or not, please just comment me in our video. Right? This is the bouncing ball concept now. But here thing you need to remember only these two. These two are most important no concept. Right? Now let us do some questions now. Some questions, right? One question now we can do it now. For elastic collision now. What is the elastic collision concept now? Elastic collision, whenever there is an elastic collision is there, so you need to remember that is momentum conservation and kinetic energy conservation. So suppose there is a one ball is there, this is one ball, mass is m, going with speed u, and it is hitting to the two balls which are at rest. All are identical balls which are at rest. These are at rest. If this ball is going on colliding onto this one now, what will happen the situation now? So they can have the options here no. Okay. So first ball is there no, it is going on hitting onto this. Therefore these two balls no, you might have seen two coins are there. Here two coins are attached. If your striker is going on hitting, it will hit to these coins. So only one coin will go out, right? You might have observed this. That we will prove it now if this collision was elastic. Let us see. So what will be the situation now? Maybe here it will be, maybe it will go like this. So it is u by 3. So second situation now, maybe these two coins will comes to stop. It will comes to stop, and only this one coin it will go out with the same speed. Third equation now. Therefore here this first ball will comes to stop, and these two balls will go with a speed of u by 2. Fourth one now. Therefore first ball will go with the speed of u, second ball will go with the speed of u by 2, third ball will go with the speed of u by 3. You have to test it. So this is elastic collision. Elastic collision now. Right. So we have elastic collision means immediately you should get into your mind. What is that? Momentum conservation. So this is before collision now. What is the momentum conservation now? Momentum initial now. If these two are not moving, this is only moving now. So therefore it will be mu. Right? Here after collision these three are moving at this one no. Final momentum how much now? This is 3m into u by 3. So get cancel mu. Okay. So momentum is possible here. This also final momentum therefore is also mu. This also possible now. Here this to stop, therefore final momentum it is 2m into u by 2, get cancel out, therefore mu. This also possible, right? This one no, mu plus mu by 2 plus mu by 3. So this is not possible. Therefore this is no chance at all in the collisions now. Right? Elastic collision now. Elastic collision means what? again one more conservation is there, kinetic energy. What is the kinetic energy? Total kinetic energy, initial and final, it will be same. Here before collision, what is the initial, what is the kinetic energy? Half m u square. This is your kinetic energy. This is at rest. So here also, therefore kinetic energy, how much it will be? Half into 3m into u by 3 whole square. Therefore it will be m u square by 3. So this is not possible. Clear? So similarly we can test for this one, no? Therefore kinetic energy is how much, no? Half into 2m into u square by 4, because u by 2 whole square. So this also it will get it as like a, sorry here, no? So this is it will get it as 6. Okay. So here these two cancel, no? Therefore m u square by 4, this is half m u square, this one, no? This also not possible. This however is not possible. So kinetic energy is how much now? It will be half m u square. So this it will be your possibility, your answer. Clear, students? Now we will do one question, no? Related to this. Okay. This is one important question. So mostly asked in the examination, no? JEE mains, no? Here condition for collisions, no? Okay. So two particles A and B are moving with constant velocity v1 and v2. Initial positions are r1 and r2. Condition for A and B should be undergoing to collision. So these type of questions, no? Therefore what you have to do? Basic condition you have to take it. What is the basic condition now? Collision means what? These two particles should come close together, no? Therefore the position of one particle, position of other particle should be same, right? So that only you can use the condition here, no? So initially what is the position of the particle A? Particle A position, particle B position. So what is the position now? R1 vector, and position of this one now? R2 vector. This is moving with velocity v1 vector and moving with the velocity of v2 vector. So after some time t, they are going to get collide. Collide means position will be the same. Position means what? What you will get it now? Initial position is there. So with velocity after some time, no, we can write down position of this one r1 vector plus v1 into t. So should be equal to r2 vector plus v2 into t. Understood? So we can rewrite it as this one now, r1 vector minus r2 vector. So this I am taking, you know, v2 vector minus v1 vector into t. Clear? So time t is equals to, time should be constant, not in the form of a vectors, no? So magnitude of r1 vector minus r2 vector by, so v2 vector minus v1 vector, magnitude. Clear? So this magnitude of the time I got it, no? So this time what we have to do? So this is your vector equation, no? So this time you try to substitute, no? You can get your, this is answer, no? Right? So here r1 vector, r2 vector, time, this is there, no? You will get it as, right? So r1 vector minus r2 vector, this time if you substitute, no, this will come down by modulus of r1 vector minus r2 vector, it will be equal to v2 vector minus v1 vector. This is time, no, denominator is already is there. So by v2 vector minus v1 vector. So this it will be your correct answer. Clear, students? Right? So one of your JEE main question, no? Please. Okay. So a body of mass m collides elastically, okay, with another stationary body of mass 3m, fractional loss of kinetic energy of the body. Right. So therefore fractional loss of kinetic energy of the body. So this is one of your NEET question now. So we need to derive. See here, elastic collision. Elastic collision means what? Here body A, this is m. Okay, let us derive this one now. Generally m1. So going with what speed u. Okay, I'll derive this equation now. Then afterwards we'll go for m2. This is at rest. So this collision will take place now elastically. After that, what will happen now? m1 will go with v1 and m2 will go with v2. Here, therefore, here before collision, no, before collision this object is having some kinetic energy. What is the kinetic energy? Kinetic energy is there now, half m1 u square. After collision, no, after collision what happened now? This was at rest, do not have any kinetic energy. So when this is got collided, so the energy of this one now is given to this. The energy of this first body is given to energy to this one now. Yes or no? Some amount of energy lost for this one now. See, in kinetic energy, energy loss is not there, no? Energy loss is not there for complete system, right? So, initial total energy, final total energy will be the same. But if you are talking only one body, if you are talking only this object, here is having this much energy, and finally this much amount of energy is there now. This is your initial kinetic energy and final kinetic energy. What is the final kinetic energy here now? So, half m1 v1 square. This is your kinetic energy, right? This much amount of energy loss will be there. Therefore, half m1, so u square minus v1 square. Clear? So, this much amount of energy loss will be there. So, he is asking fractional energy loss, no? Therefore, by half m1 u square, this will be your fractional energy loss, no? Therefore, you can rewrite it as, so u square, therefore, you can write on 1 minus, so v1 by u whole square. This is your fractional loss of kinetic energy. Therefore, kinetic energy by initial kinetic energy. Clear? Now, we want to calculate v1. So, what is the formula we written now? v1 is equals to, we written yesterday, u1, so plus, therefore, here u2 was 0 because it is at rest. So, this how much now? This is m1 minus m2 by m1 plus m2, correct? Elastic collision now. This was 0. This entire thing will be the 0. Now, what you can write it now? Right? So, here v1 by u, that is u1 is nothing but u, is nothing but m. So, m1 minus m2 by m1 plus m2. So, if you want to get whole square onto this one, no? So, square it and square it. No? You can a plus b whole, a minus b whole square, m1 square plus m2 square minus 2m1 m2 by m1 square plus, in this equation, no? What you can get it now? Fractional loss of kinetic energy. Therefore, kinetic energy 1 minus v1 by u whole square. Substitute here, no? 1 minus this one, you can substitute this entire thing, no, in this one, no? Simplify m1 square plus m2 square plus 2m1 m2 minus m1 square minus m2 square plus 2m1 m2 by m1 plus m2 whole square. These two will get cancelled out. So, you will get it as 4m1 m2 by m1 plus m2 whole square. So, this it will be the fractional loss of kinetic energy of the colliding body, right? This is one of your NEET question, right? So, for NEET, no, this formula 2019, this is your NEET question, 2019 NEET question, NEET, clear? So, here what we got it now, fractional loss of kinetic energy 4m1 m2 by m1 plus m2 into m2 whole square. So, just we can substitute it and we can get your answer, no? Next time if they are asked, no, if you practice this formula is enough. So, therefore, we can get it as colliding body. This is 4m into 3m divided by, so m plus 3m whole square. What you will get it now? So, therefore, it is 12 m square. This is 4, 16 m square. Get cancel out, no? So, here 4 3s are 4 4s are, therefore, 3 by 4. So, answer is 3 by 4. Clear? So, next time no need to derive onto this one, no? So, next time just remember this formula, you can get it now, right? We will do one question, no? One more question here, no? If the two balls of each masses 0.06 kg moving in opposite direction with a speed of 4 meters per second collides and rebound with the same speed, is asking impulse imparted to the each ball. That means two balls are there. They are coming and colliding here, no? Oppositely. After colliding, so they are rebounding with the same speed. What will happen now? Here. So, here they are collided, no? Okay. So, before this, what happened now? This side one speed is there, this side one speed is there. After collision, no? They are going back like this. They are asking impulse. Impulse means, you remember that impulse means that is nothing but a change in momentum. So change in momentum, here it is, this side one speed is there, that is momentum is there. After collision it is coming back. So therefore initial and final are opposite direction, no? So change in momentum will become like a addition of this, yes or no? P final minus P initial, no? Suppose if you take this is your direction, no? Initial this one, no? Final is this one, no? So therefore opposite to this, minus P minus no, therefore minus 2pi. So minus 2 into momentum is how much now? Mass is how much now? 0.06. 0.06 into velocity is how much now? 4. So therefore minus 2 into 0.624, no? Therefore 24. So 0.48 kg meter per second minus 0.48 will be your answer. Like this, understanding the question is more important, no? Right? Clearly? Now, a ball is dropped from a height of 10 meters, a 40% of energy lost in the collision. So with the earth, no? After the collision, the ball will be rebound to the height of. So here, so what happened now? There is a one ball is there, it will be falling to here. So it is hitting, and when it is hitting, 40% of energy lost. Initial energy is how much now? Initial energy is nothing but a mgh. So then it is lost now. How much energy is there now for this one now? It will be having 60% of the energy. 60% of the energy, that means this height is about 10 meters. So 60% of the 10 meters is nothing but a 6 meters. That is your answer. Clear? Okay. So most of the times now they will ask coefficient of restitution. What is the coefficient of restitution formula? Square root of h1 by h0, because first bounce only, no? So therefore here what you can write it now? h1, that is h1 is equals to e square into h0, correct? Like this. So h1 is what? h1 means after first bounce, 6 meter divided by 10. Therefore root 0.6 will be your coefficient of restitution. They may ask you like these questions. Clear? Yeah, the sphere of mass m moving with constant velocity collides with another stationary sphere of mass, same mass. Okay, so here a sphere of mass m moving with constant velocity collide with stationary. So therefore this is one going with v, going with u, so identical. This is at rest. Therefore this collision was inelastic. Clear? What we have to do now? So we want to calculate. Therefore we know v1 is how much now? v1 is nothing but it is u plus u1. It is u2. u2 term we can take it as rest, no? So this is at 0. Therefore you can just remove this part, no? Therefore here you can write it as m1 minus e times of m2 by m1 plus m2. How I written this equation now? Please check it in my first video. How I written collisions first video, part 1. So therefore you can get it now. Identical masses here now is m and m, 1 minus e by 2 into u, right? So similarly v2 we can write down. So therefore here it will be u1 plus u2 term, it can be taken as 0. So what you will get it now? Here 1 plus e into m1 divided by m1 plus m2. Have I written this one now? Also please check my video, first video. So then you will get it as, so identical masses 1 plus e by 2 into u. So you can divide this one now. Therefore v1 by v2 you can take it as u by 2 you can take it cancel here, no? 1 minus e by 1 plus e. So 1 minus e by 1 plus e, please. This is your answer now, right? So like this you can able to solve some questions, no? And some more, one more video we will make it on the collisions, especially only numericals. If you want to right, so if you want to be thorough onto this one, no? So please go through my first part video and second part video, then come back to the third part. So we will discuss fully numerical problems related to the collisions now, right? Thank you for watching. Please subscribe to my channel now, please.